Hello, my dear children. Myself Sujata. In the last class, we learned about the difference between weather and climate, six major controls of the climate of any place, and the factors affecting India's climate. In this session, we will learn about the Indian monsoon, the mechanism of the monsoons, and the onset of monsoon and its withdrawal. Okay, first let us discuss about the Indian monsoon. The climate of India is strongly influenced by monsoon winds. Monsoon refers to the seasonal reversal in the wind direction during a year. The sailors who came to India in historic times were one of the first to have noticed the phenomenon of the monsoon. They benefited from the reversal of the wind system as they came by sailing ships at the mercy of winds. The Arabs, who had also come to India as traders, named the seasonal reversal of the wind system monsoon. So, monsoon refers to the seasonal reversal in the wind direction during a year. Okay, this map shows the atmospheric condition of the Indian subcontinent in the month of January. This map shows the atmospheric conditions over the Indian subcontinent in the month of June. The monsoons are experienced in the tropical area roughly between 20 degrees north and 20 degrees south. To understand the mechanism of the monsoons, the following facts are important. So, the monsoon refers to the seasonal reversal in the wind direction during a year. Let us see how it happens. The differential heating and cooling of land and water creates low pressure on the landmass of India, while the seas around experience comparatively high pressure. So, the seasonal reversal of wind direction takes place because the land and water have different rate of heating and cooling. When the land is warmer, the pressure is low. When the water is colder, the pressure is high. So, the wind blows from high pressure to low pressure. Therefore, a seasonal reversal of wind direction takes place over the Indian subcontinent. Another important fact is the presence of the high pressure area east of Madagascar, approximately at 20 degrees south over the Indian Ocean. The intensity and position of this high pressure area affects the Indian monsoon. The Tibetan plateau gets intensely heated during summer, which results in strong vertical air currents and the formation of low pressure over the plateau at about 9 km above sea level. The movement of the westerly jet stream to the north of the Himalayas and the presence of the tropical easterly jet stream over the Indian peninsula during the summer also affects the monsoon. As you have learned earlier, jet streams are a narrow belt of high altitude, that is about 12,000 meter westerly winds in the troposphere, and its speed varies from about 110 km per hour in summer to about 184 km per hour in winter. So look into a map for easier understanding of it. Okay, this diagram well explains the intertropical convergence zone. You can see the equatorial latitudes and as well as the movement of it towards north or south with the apparent movement of the sun. Apart from this, it has also been noticed that changes in the pressure conditions over the southern oceans also affect the monsoons. Let us see how it happens. Normally, when the tropical eastern South Pacific Ocean experiences high pressure, The tropical eastern Indian Ocean experiences low pressure. But in certain years, there is a reversal in the pressure conditions, and the eastern Pacific has lower pressure in comparison to the eastern Indian Ocean. This periodic change in pressure conditions is known as the Southern Oscillation, or shortly SO. The difference in pressure over Tahiti and Darwin in northern Australia is computed to predict the intensity of the monsoons. Located in a map for easier understanding. Let us see how we can predict the intensity of the monsoon. If the pressure differences were negative, it would mean below average and late monsoons. A feature connected with Southern Oscillation, or SO, is the El Nino phenomenon, in which a warm ocean current that flows past the Peruvian coast in place of the cold Peruvian current every 2 to 5 years. The changes in pressure conditions are connected to the El Nino. Hence, the phenomenon is referred to as ENSO, or El Nino Southern Oscillations. Okay, this picture shows the movement of wind based on the temperature differences. Okay, now let us understand what is El Nino in detail. This is a name given to the periodic development of a warm ocean current along the coast of Peru as a temporary replacement of the cold Peruvian current. El Nino is a Spanish word meaning the child and refers to the baby Christ as this current starts flowing during Christmas. The presence of El Nino leads to an increase in sea surface temperatures and weakening of the trade winds in the region. Okay, now let us discuss the onset of the monsoon and withdrawal of it. The monsoon, unlike the trades, are not steady winds but are pulsating in nature, affected by different atmospheric conditions encountered by it on its way over the warm tropical seas. The duration of the monsoon is between 100 to 120 days from early June to mid September. Around the time of its arrival, the normal rainfall increases suddenly and continues constantly for several days. This is known as the burst of the monsoon and can be distinguished from the pre monsoon showers. The monsoon arrives at the southern tip of the Indian peninsula, generally by the first week of June. Subsequently, it proceeds into two: the Arabian Sea branch and the Bay of Bengal branch. The Arabian Sea branch reaches Mumbai about 10 days later on approximately the 10th of June. This is a fairly rapid advance. The Bay of Bengal branch also advances rapidly and arrives in Assam in the first week of June. Okay, now look at this map and understand how the monsoon advances. As we said earlier, the duration of the monsoon is between 100 to 120 days from early June to mid September. The lofty mountains causes the monsoon winds to deflect towards the west over the Ganga plains. By mid-June, the Arabian Sea branch of the monsoon arrives over Saurashtra Kutch and the central part of the country. The Arabian Sea and the Bay of Bengal branches of the monsoon merge over the northwestern part of the Ganga plains. Delhi generally receives the monsoon showers from the Bay of Bengal branch by the end of June. Tentative date is 29th of June. By the first week of July, western Uttar Pradesh, Punjab, Haryana, and eastern Rajasthan experience the monsoon. By mid-July, the monsoon reaches Himachal Pradesh and the rest of the country. Okay, now let us discuss about the withdrawal or the retreat of the monsoon. Withdrawal or the retreat of the monsoon is a more gradual process. The withdrawal of the monsoon begins in northwestern states of India by early September. By mid October, it withdraws completely from the northern half of the peninsula. The withdrawal from the southern half of the peninsula is fairly rapid. By early December, the monsoon has withdrawn from the rest of the country. Okay, from this map given, understand the withdrawal or the retreat of the monsoon. The islands receive the very first monsoon showers progressively from south to north from the last week of April to the first week of May. The withdrawal takes place progressively from north to south from the first week of December to the first week of January. By this time, the rest of the country is already under the influence of the winter monsoon. Okay, in this session, we have discussed about the Indian monsoon, the facts that support the mechanism of the monsoon, and the duration of the monsoon and its withdrawal. So, now try to watch the slides again and again. Meet you in the next session. Thank you.